Alrighty, good evening, everybody, and happy Easter. Um, I wanted to do a small lecture, not too long. Last week you learned about the sine law and the cosine law. I put both laws up here at the top. You should remember that the law of sines kind of looks like this. Sine of some angle over the side equals sine of another angle over the side. And then hopefully you also remember the law of cosines, which kind of looks like a elongated Pythagorean theorem. But obviously the sine law has sine and the cosine law has cosine. And I'm hoping you also remember from last week that every time we see a capital letter in these equations, we're referring to an angle. And every time we see a lowercase letter in these equations, we are referring to a side. So my goal in this video is pretty much to get you to develop an intuition for the formula that you would use in different scenarios, because when you're given a triangle, you need to decide whether the sine law is more appropriate in that case or whether the cosine law is appropriate in that case. So I'm going to hopefully point out a couple things to you. So first thing I want you to notice that in the law of sines you have two angles involved, right? There's two capital letters and two lowercase letters. So that pretty much means that in order to use the law of sines, you either need to know two angles and a side or two sides and an angle. So that is the scenario that we're looking for. And then when you're looking at the law of cosines, notice that all three lowercase letters make an appearance, and only, I should have highlighted these two. So notice that all three lowercase letters make an appearance, only one capital letter makes an appearance. So this information is helpful because it's going to be one of the main reasons that we're able to choose between the law of sines and the law of cosines. So the first thing that I put in this table you can find in Canvas. I made its own little page. I just screenshot it to kind of show you. So we're noticing in the sines case that we can use the law of sines. So we can use the sine law whenever we have knowledge of more angles. In general, there is a case where knowing more sides is going to help you with the law of sines, but in general, if you know more angles, then the law of sines is a little more helpful. And in the law of cosines, so I'll highlight it over here. In the case of the law of cosines, notice that because all three sides are involved, that's going to help if you know more sides. Okay, so you might remember from Integrated Math 1, Integrated Math 2, you learned about these, at the time they were called triangle congruence theorems or triangle similarity theorems. And we're not exactly looking at the theorem. We're not trying to prove if two triangles are congruent or similar, but we are using the same labels to determine which theorem we're going to find more beneficial. So I'll show you what I mean. So right here, notice it says case 1 and it says ASA. So let me show you what I mean by ASA. So notice that up here, every time that I had a capital letter, I highlighted it in yellow. And every time I had a lowercase letter or a side, I highlighted it in green. So let's go to the picture. Let me blow it up real quick. And I want you to notice that in this triangle, I have one side, right? So I can call that A. And then I have two angles right here. Oh, sorry. I don't know why I called that A. Sorry, that should be a side because that's a side of a triangle. And then these ones here are A's. Let me write it in black because I think the yellow might not show up, right? So as you can see, you have the case where there is a side trapped between two angles. So this side is trapped, right? See how it's literally stuck right in between the two yellow angles. So whenever you see a side length stuck between two known angles, just like this, that's going to be one indicator that we can use the law of sines. So I'm going to go ahead and draw right here. So that's going to be the sine law, okay? And then you'll notice again, down here at the bottom, we have another case, AAS, right? And I gave you an example of AAS down here. So I'm going to mark the triangle the same way. So notice that I have two angles again, right? So I'm going to call that A. But this time notice that we're in the top example, the side was stuck right here in between the two angles. Now it is not. It is over here off to the side. So that is a different case that we call AAS, or you could call it SAA, either one. Normally, I think I normally write AAS. But you can see that that is a side length that is not stuck between two known angles. And that's going to be another case where you're going to use the law of sines. Okay, so the takeaway here is I want you to kind of internalize that whenever you have, let me erase this real quick. So notice that in both of these cases, we knew more angles than sides. See how here we had two angles, one side. Here we had two angles, one side. So whenever you have scenarios like that, the law of sines is probably going to be your way to go. And it also, keep in mind, it depends what they ask you, but it's typically, if I use the law of sines here, I would be able to figure out, I could figure out this angle, then I could figure out this side, and then I could figure out that side. So, it's just, it's more like a guide than it is a rule of thumb. And over here, we're going to go with the law of cosines. So again, notice in the formula, you have all three sides involved. Whereas with the sine law, you only really had two sides involved. So we're looking for cases where more sides are in the picture. So if you know more sides than angles, that's probably going to be a clue for the law of cosines. So here's the first example, very classic example. All three sides, right? So we call that S, S, S. So in the case of SSS, where the law of cosines will help us find the unknown angle. And again, we have another case where we have more sides. So in this case, we have two sides, and we know one angle, right? So we would call this side, angle, side, because the angle is stuck in between the two sides. So that would be side, angle, side. And again, notice that these cases, what they have in common is more sides than angles, right? So when you're doing the activity, I want you to kind of internalize this and ask yourself, okay, what case do I have? So here, notice here we have angle, angle, and then a side. So this one we would call A, S, right? So again, if we have AAS, ask yourself, is that more angles or more sides? Well, I see more A's than I do S's, so that's more angles. And if we have more angles, which rule is that? That would be, law of sines. Okay, so this would be a really good example to use the law of sines on. Okay, let's go down here. Here we have angle, angle, and we have a side stuck between, right? So this one would be called angle, side, angle. So again, if we have ASA, ask yourself, do you know more angles or do you know more sides? Well, you see more A's than S's, so that's going to be more sides. More angles, which again is going to be sine law. Oops. So the sine law will help you find this. Just keep in mind that you will need to find this angle first in order to do, big A over little a, big B over little b. But again, you're still going to be going with the sine law. Now over here, look at these cases. In this case, notice that we have only sides, right? So that would be the case where we call it S, S, S. And if we have SSS, we ask ourselves, do we know more angles or more sides? Well, we know only sides, so that's going to be a cosine law. And then if we had this one down here, notice that we have side, another side, and angle stuck in between, so that would be what we call side, angle, side. And if we have side, angle, side, again, we ask ourselves, do we know more angles or more sides? Well, it looks like we know two sides, but only one angle. So again, that would be cosine law. Okay, and I do want to mention, just real quick, you might come across one other case. So this is one of each, the side, angle, side, angle, side, angle, side, side, or side, angle, side. There is one more case called the side, angle. Okay, and in this case, it's actually an interesting case. So if you had, for example, a triangle, and you knew, let's say this side was 10, this side was 20, and you knew this was, 40, right? And you want to, it depends in this case what you want to know. I mean, it depends in all cases what you want to know, but in this case, if you wanted to know this angle right here, then you could easily use the sine law. But, you could easily use the sine law. But if I asked you instead for this side, then you would have to use the cosine law. So just keep in mind that for the case of side, angle, side, even though there's more sides than angles, it could go both ways. Okay, so both ways depending on what they're asking for. Okay, so just keep that in mind. It is a helpful little trick to choose between the laws. Again, I want to reiterate, it's not a rule of thumb. It doesn't mean that you can have it. It really depends what's also asked for. Asking for an angle is different than asking for a side, and so this is just kind of guidance. Like if you see the case of AAS, most likely law of sines. If you see the case of ASA, then you have the ability to use law of sines. But just keep in mind that it could, you still have to use discretion and logic to figure out which one actually makes sense. Okay, so that's pretty much our short little lecture today. There's a Desmos activity for you to complete just to get you practice choosing which case you see in the triangles and which ones would use sine or cosine.